Alright, everyone. Hello for today's episode in PyBrain. I've been making tutorials on basics so far. The basics of Python, data types, for loops, while loops, functions. I thought I might make a video now about a special topic, and that topic is genetic, some sort of genetic programming. It's more specifically, it's called genetic algorithms. So you can see here from the screen, I have this PDF open up. It's a book. It's as you can see here on the top, the book's called Genetic Algorithms with Python by Clinton Shepherd, and it's a PDF book. You could find it online. You could buy the book as well. Anyway, so this program that we'll discuss today is a genetic algorithm, and you could consider it to be the hello world of genetic algorithm. So it says here, you can see that we're dealing with genes. It says to begin with, a genetic algorithm needs a gene to use for building guesses. So essentially what we're doing here is, the goal of this genetic algorithm is to have the computer or the program evolve. So basically the idea of genetic algorithms is that we're using biology as a analog. So you could consider that in evolution we know that we have populations. Each individual within the population has genes. Those genes will be transmitted to the next generation. A breed, or they swap their genes, basically will become swapped in a way. So you could consider that in programming we could also specify these sort of processes in a computer program. Let's say we wanted to have a program evolve the statement hello world. To do that, we would have to first specify a gene set given by this variable gene set. You can see it's equal to the alphabet, where you have lowercase with uppercase letters. You have some special characters such as this exclamation point, the percent, the dot or decimal, and we also have a empty space, and that's because our target is hello world, and that has an empty space here and an exclamation point, including some uppercase and lowercase letters. And so if we have this gene set and we have a target, we can then generate a guess. So the guesses, of course, will be random. So we would have to use this random library or module. Then we have a function, which you can see here is defined here with the keyword def, generate a parent. So the parent is going to be generated from this function. It takes in a value length, which is going to be the length of characters. So then you can see here that within this function we have this variable gene. It is an empty list, and then we get a while loop. So now we say while the length of genes is less than length, sample size equals min length minus length of genes, and then we have length of gene set. So this part is actually a little bit complicated. We'll discuss that after a little bit later. And then here we have genes.extend. Okay, random.sample gene set, sample size, return, and then we join the genes with an empty space. So we can see here from the description that random.sample, which is this part here, this takes the sample size shown here, which is a value from the input without replacement. And so the sample size was also defined here, and it is the minimum of either of these two values. And so one of the values is length minus length of genes, and the other value is the length of the gene set. And we can see over here the length of the gene set is the whole alphabet plus these other special characters and capital and lowercase letters. Alright, so let's get started, and we could open up a terminal with Control-Alt-T in Linux. You could also use PyCharm if you're on Windows. On Mac, it's essentially the same. You could use the terminal. And I'm going to go to the programs, and I'll go to Python tutorials. So you can see I have one of my other examples here. So I'm going to create a file here, which I'll call, we can see here from the book, it's guesspassword.py. Or actually, I believe we should say, since this is actually generating hello world, let's say that this is actually called hello world.py. Okay, so inside here, we're going to import random. We're going to specify the gene set. And as you can see, I have a transparent terminal, so I could actually see some of the book text from here. So the gene set is, and I'll go ahead and copy this. I hope this works. I'll find out right now. Yep, it worked. And we got our gene set, we got our target, which is hello world, exclamation point. And so now that we have those variables set, we could then specify or define this function to generate a parent. So define generate underscore parent and length colon enter, and then indent, which I just pressed tab. So here we have genes is a empty list, then we have a while loop. So while the length of genes is less than length, sample size equals min length minus length of genes and length of gene set. Then we have genes.extend random.sample gene set sample size, two parentheses, and finally once the while loop is done, we return this operation, which is quote dot join genes. Okay, so let's see what's going on here. So we have, let's say we're doing, let's run this with right here one time with generate parents. Let's say length would be, let's say length is 15. Alright, so honestly, I never ran this before and I don't know what it's gonna output, and I should have put prints here, otherwise I can't really see what the output is. Okay, so we get some weird output. You can see here, looks like some random mix of alphabetical characters, uppercase and lowercase. And so if we want to actually know what's going on here, well, we have to look up some of these things here. So let's go back here to the book, and we could see that the random.sample will take sample size values from the input without replacement, and that is used here. And so basically we're saying we're going to take from the gene set, which is this whole alphabetical string here. From that, we're going to take random characters, and how many we take out is given by sample size. So the sample size was 3. We're going to take 3 of these characters without replacing them. So for example, if the first character we get out from gene set is capital A, then that means that the next random character we choose cannot be capital A again. And if I go back to the terminal, you can see that no character repeats again. So this capital X is here. There's no other capital X here. Okay, so we have a lowercase u here, and then a capital U over here. Yeah, so essentially the random.sample is choosing random characters from this first variable according to this value of sample size. Now our sample size is going to be given by this function, which min is minimum. Here, let me open up another terminal and I'll just type in Python. So let me say min. Let's say I run the min function between, let's say, values of 20 and 10. Alright, so it gave 10. And so you could tell that it's just returning the smallest value that you're giving it. So in this case, we got 2 values separated by this comma here. So the first value is given by length minus length of genes. Our length is here. So if I specified here, I'll cat it. If I specify that I wanted to generate a parent with length of 15, that means that this has 15 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Alright, just to be sure. So we generated a string of 15 characters, and that's what the length is. Now if we go back to the here, we could see that, so length, which is, let's say in our case 15, minus the length of the genes, and remember the length of genes is going to be whatever this is, the genes here. This genes variable is a list. So right now, in the very first step, there is nothing inside of the genes list, so the length would be 0. So we would have the minimum between 15 minus 0, which is 15, and length of gene set. Length of gene set is this whole thing here. So, let's go back here to the... Alright, I got so many terminals open. But okay, here we go. So let me go back inside the code, and we'll type in, let's say we want to print the length of gene set. Oh, I meant to run. Okay, let me clear the screen. Python. Okay, we can see that the length of the gene set is 55. So we go back here. There's 55 characters here, or items, you could say. And so basically, now we're saying pick the minimum between 15 or 55. Of course it's 15. So then we go on to the next step, which is take, and so since this is 15, since sample size is now 15, we're saying take 15 random characters from gene set without replacing any of those items. And then we're going to run this genes.extend, which I'm not actually sure what that is, but we could always look that up. If I go here and just type in Python list extend, and I'm guessing it's just going to extend the list, but let's see how that actually works. Alright, so right here in this website, W3 Schools, is a very good website. So, it's always good to look things up online if you're ever having trouble or forgetting something. I mean, we're not robots, right? But there's a good method to solve issues. You gotta know how to look things up. Okay, so here we have two variables. They're both lists. We have fruits and cars. Some pretty popular brands here for cars. Some popular fruits. We're running now fruits.extend cars. So it says here the extend method adds the specified list elements to the end of a current list. Okay, so I think I get it. And I want to just make sure you guys understand as well. So let's say we have two lists. Our first list is, let's say, list A. And I just want to go off by their example. Let's say that, with the fruits and the cars. So we'll have the first fruit is an apple. Then we have an orange. For list B, let's say this is also cars. So I'll have two car brands in a list. So I'll have, let's say, Honda and Toyota. Alright, I think that's how you spell it. So now let's say we run list A dot extend list B. So I believe list A should now have list B included. Yeah. So we can see that list A has been modified after this operation with a dot extend. So you can see that now it includes the oranges or the fruits and now the cars as well. So we basically like tacked on the list B items onto the second half of list A. So I hope that makes sense. And so essentially here we're generating these this string of 15 random characters that we're basically removing from the gene set, this whole alphabet thing, and then we're adding them here to the genes list. So if I want to go back now to the program, and where is it? Okay, here it is. Let's go back in here, and I want to show you guys how this actually looks like. I want to now print genes, so we're going to see how genes is evolving as it is being developed. Okay, so we see right here that genes is, you can see here, it has Q, N, and we can see that these also are present on the final output here. So basically the genes list is a list of all the characters individually as strings, and finally the dot join will join them into one single string. So let's cat the function, or the function. So we can see here that, so right here we are basically generating we're grabbing all the 15 random samples from the gene set, which is the alphabet basically, 15 of them, and we're adding them to the genes list, but we don't want them in a list format, so we will return them as a single string, and that is done by running this join operation, where we will join up all the items in genes with no spaces in between them. That's how we just have two quotes here, no space in between. Okay, I hope that makes sense for everyone. And so you can see that this function is basically allowing us to generate a parent. So let's say that I could modify this a bit. Let's say I wanted to generate 10 parents for I in range 10, colon. Okay, I don't need this other line here. You know what, I'll just remove it. Okay, let's say I want to generate, alright, well, I'll just leave it 15. So let's say I want to generate 10 parents, and we'll be printing them out. I don't want to print out the genes here. This was just to show you guys what's going on inside that function. Also, I want to say, once you're working with Python on your own projects, using print functions is very good to see what's going on inside any kind of indented block of code or anything. It helps you see how the variables are being developed. Anyway, so now that I have a for loop with range of 10, I want to see what kind of output we get. Alright, so you can see here these are 10 parents. Each of them have random unique characters, 15 of them to be exact, from the gene set, which was the alphabet. Okay, so that's the first part of this, and I don't want to make a super long video, so I'm sure it's already very long. I haven't taken a look at the time, but I want to split this up into many videos, and so I hope you guys learn something useful here. And this is the first part of making the program that will ultimately create hello world as a string through a form of evolution using Python. Alright, you guys, well, I'm gonna end the video here, so I hope you guys enjoyed it. Make sure you like and subscribe.